my name is Pamela. Welcome to my channel. Today I'm gonna talk about the displacement type level sensor consists of a float partially submerged in the liquid and connected by an arm to a torsion tube rigidly attached to the tank. The torsion tube is characterized in that the angle of rotation of its free end is directly proportional to the applied force, that is, to the momentum exerted by the float. The angular movement of the free end of the torsion tube is very small, on the order of 9 degrees. The tube provides a tight seal between the float and the outside of the tank, which is where the transmitted torque receiver instrument is. According to the Archimedes principle, the float undergoes an upward thrust that is given by this formula. Therefore, we calculate the momentum on the torsion bar with this other one. As we can see in the formulas, when the level increases, the liquid exerts a thrust on the float equal to the volume of the submerged part multiplied by the density of the liquid, having to neutralize its own weight. So the effort measured by the tube of torsion will be very small. As the level drops, less of the float is submerged and the thrust force decreases, causing more torque. These instruments are widely used for dirty fluids and high temperatures. This instrument can also measure the interface between two immiscible liquids of different density. In this case, the float is small in diameter and large in length, and it is totally submerged. The weight of the volume displaced by the float, that is, the thrust, has two parts, that of the densest liquid in the lower part and that of the less dense liquid in the upper part, with a separation line on which the torque depends provided to the transmitter. To calculate it, we use these formulas. We can see that the thrust depends on the relative level of the separation of the liquids, and that the amplitude of measurement is determined by the difference between densities of the liquid. This instrument is also used to measure the density of the liquid, and for this, the float is completely submerged. The range of density measurement is 0.4 to 1.6. The meter body can be mounted internally or externally. In the internal mounting, it goes directly into the tank, and in the external mounting, on a vertical tube next to the tank. The length and diameter of the float depend on the measuring range. The accuracy of differential pressure instruments is plus minus 0.5% for pneumatic, plus minus 0.2 to plus minus 0.3% for electronic ones, plus minus 0.15% for smart ones with a 4 to 20 milliamperes DC signal, and plus minus 0.1% for those using open and closed pressure tanks and vacuum. Their advantages are that they have no moving parts inside the tank. They are easy to clean, they are accurate and reliable, they support fluid temperatures of up to 120 Celsius and are not influenced by pressure fluctuation. As a disadvantage, they have that in closed tanks it is possible that the tank vapors condense in the connection tube to the instrument, which can be eliminated with a suppression spray, of which I've already talked about in past videos. As for the diaphragm material, it must resist the corrosion of the fluid and can be 316 stainless steel, mounted, tantalum, halstoy B, and stainless steel coated with Teflon. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adiós!